Good morning, good evening, or good afternoon, depending on where you're joining us from today. I'd like to welcome you to our live session today, Cloud Infrastructure Automation. Before we get started, I'd like to go through a little bit of housekeeping with you. We will be taking Q&A today throughout the webinar, and you do have on your webinar console a Q&A box. If you find that you have technical or content-related questions, please use that window, and we will try to address those questions as they come in. It's possible that we will wait until the end and address some of your questions. Please be patient with us. You will receive a recording of this webinar in your email within 48 hours after the webinar is over, so please know that you will have another opportunity to view the webinar. We are live today, so if you tend to have any issues with your reception, please try refreshing your browser. That often solves the problem. Today we have two speakers with us, and I'd like to quickly introduce them. Zachary Deptawa, he's a cloud developer advocate at Microsoft, and Nick Jackson, a developer advocate for HashiCorp, will both be joining us. Zach, I'm going to go ahead and hand it over to you.
Okay, thank you. Good morning, everybody. Thanks for joining the webinar. I am Zachary Deptawa, cloud developer advocate from Microsoft, as mentioned, and let's get started. So today we'll talk on a high level of the partnership between Microsoft Azure and HashiCorp Terraform. Some of the newer Azure resources for the Azure RM provider and Terraform, using Terraform with Azure to enable repeatable, consistent deployments, the Terraform module registry, and some Azure modules. And we'll also talk about how to use Terraform from a high level, followed by a demo to tie all of it together. We will also touch on challenges for operators to provision in a highly dynamic and distributed cloud environment, the value of Terraform and how to use Terraform as you scale across teams, as well as the ecosystem of partners. So I know some of you may or may not be familiar with who HashiCorp is, so we'll start there. HashiCorp was founded in 2012 by Mitchell Hashimoto and Armin Dadgar. Mitchell and Armin both observed as operations engineers that the world was shifting to cloud infrastructure. So what they also noticed there was quite a gap in tooling available to operations professionals at the time to help provision, secure, and run their new cloud infrastructure. Each cloud provider seemed to have their own unique proprietary tooling in place, and along with that came some challenges. Using these tools would generally lock your applications into that particular environment. So it also left the typical gap that you would think of when you think of varied environments, usually very little similarity in how those environments were managed. So to Matt and Armin, these tasks required, the tasks required for this to provision, secure, and run diverse infrastructure were pretty similar to those performed for the traditional infrastructure, but more in tune with challenges of distributed cloud technologies and topologies. So they set out to build HashiCorp as a product suite for operations professionals to help provision, secure, and run hybrid cloud infrastructure without being tied to a particular platform or technology. And HashiCorp is mainly known by its product that you can see listed here. In fact, you may or may not be aware that all of these products are actually provided by HashiCorp. They're usually known by the product name. The key products offered by HashiCorp are Terraform, which we're going to talk about today, Vault, Consul, Nomad, Vagrant, and Packer. And these tools are very, very commonly used, so it's possible that they're already in use at your company in some shape or form. So now we'll talk for a second about Microsoft's cloud computing and services platform called Azure. And how does it differentiate from other cloud hosting providers? These four pillars represent the main value proposition for Azure. We focus on providing unparalleled productivity with integrated tools from mobile DevOps to serverless computing. We offer 100 services, over 100 services that support the latest open source technologies. You can use any dev tool, any language to easily modernize your applications to your heart's content. Our platform can help accelerate application delivery using agile development practices like continuous integration and delivery while you build software atop popular software and tools. We care about real hybrid consistency and flexibility. You can deploy Azure Stack servers as a local extension of your Azure environment in your data center, or enable consistent user experience with common identity by deploying something like Azure Active Directory for single sign-on. We help you create next generation of intelligent applications using powerful data and artificial intelligence services. You can build and deploy custom AI models at scale and develop breakthrough applications with built-in intelligence using a comprehensive set of services. We have earned the trust of countless startups, governments, and 90% of Fortune 500 companies who run the Microsoft Cloud today. We meet stringent requirements of international and industry-specific compliance standards, such as HIPAA, FedRAMP, SOC 1, SOC 2, etc. In fact, we are compliant with more certifications than any other cloud provider today. These are the main reasons why customers continue to choose Microsoft Azure every day, and we offer a very unique value to be productive, hybrid, intelligent, and we are a trusted cloud. And so now we're going to be joined by Aaron Chandrasekhar, who is a Principal Program Manager for Azure Open Source and Integrations at Microsoft. He's going to give us an update on recent activities by both Microsoft and HashiCorp engineering teams. So Aaron, take it away.
Thank you, Zach. Our engineering team at Microsoft has been working closely with HashiCorp engineering over the past several months to deepen Terraform support for Azure compute and networking resources. We now have a significant amount of customers using Terraform with Azure. Based on feedback from our customers, the team is currently focusing on more sophisticated enterprise-grade networking resources, higher-level Azure services, as well as tools for authoring and testing Terraform modules and templates. You can keep up with all this new feature support by bookmarking the Azure Provider repo at aka.ms/tfrepo. The related content in terraform.io is at aka.ms/terraform. We also have a new Terraform hub in Microsoft.com with tutorials and articles which you can visit by going to aka.ms/tfhub. Finally, we take all customer feedback very seriously and use this to prioritize our engineering backlog. So please feel free to send your feedback and or questions directly to me at achand@microsoft.com. Back to you, Zach.
Thanks, Aaron. Let's jump into some challenges surrounding cloud operations. So when an operations team has to deploy and manage an application, they're typically dealing with a few things. Operations management of the infrastructure the application runs on, security of both the infrastructure and the application, and development and improvement of that application. So when you think about what that means for an application to be redundant, fault-tolerant, decoupled, highly scalable, what you're talking about is a multi-component application that spans a data layer and a runtime layer. This means the infrastructure almost certainly has heterogeneous elements spanning several VMs or containers, and it might still even include physical gear or servers. So operations teams are often burdened with not only provisioning this infrastructure, but also with making sure the environment is consistent and secure at both the infrastructure and app level. What this means is they need to make sure the application is deployed atop the infrastructure in a repeatable, secure, testable, consistent manner, as well as registering the infrastructure and application with various monitoring tools to ensure uptime. What we're really talking about here is an end-to-end software supply chain. So these principles have not changed for quite a while. Just as any factory with newly improved products would need to retool that factory to accommodate the new version of that product or its components, the software supply chain requires new tooling to support the evolution of modern application infrastructure. It's sometimes hybrid, most often highly distributed, and is much more dynamic than what previous tool chains were designed to handle efficiently. The traditional approach to infrastructure was relatively straightforward. Infrastructure layer was composed of physical servers running in racks in a data center somewhere, and the runtime layer was either directly on those physical servers or was running in virtual machines. The typical application was often decoupled over only a few servers or virtual machines. As an example, maybe a 3-tier app, one server or VM running a web server, one running as an application server, for example, one running as a database server, maybe 3 or more servers or VMs for redundancy in a cross-connected cabinet somewhere with a load balancer. And as traffic and usage increased, the approach was actually to scale up by adding more compute power, so upgrading the processor and or RAM of those servers. Full-on painful server replacement to increase that server or hypervisor CPU and or memory totals to allow for some breathing room at the runtime layer. It was often more painful or expensive to reconfigure your application or rack to allow for you to scale out your infrastructure around this time, by increasing the number of servers that you had. Around this time, cloud was showing the elasticity and a sneak peek of the scalability it offered. Businesses started exploring the use of a hybrid model, an elastic front end and application layer with a dedicated or beefier database backend, usually hosted on physical machines or hypervisors. But there was a bit of a struggle. For this kind of setup to work, you need a few things. So you need connectivity from the dedicated private cloud segment of your hosting provider to either that same provider's cloud or even another cloud altogether. You need automation to easily spin up reusable bits of code for your configuration and application on virtual machines in the public cloud. And you also need the ability to create and update infrastructure quickly and reliably. So enter Terraform, a tool that would allow for automated infrastructure as code across varied platforms. No more vendor lock-in with proprietary tooling. Your infrastructure was now easily portable and scalable with the possibility of sharing the same configuration across diverse platforms. Terraform enables infrastructure as code for automation. The input Terraform takes is a Terraform configuration composed of resources that are expressed as code. Operators can build a holistic configuration for their application, or they can choose to represent their infrastructure as modules to make it easier for infrastructure components to be reused, just like functions in an application. Terraform also has a public module registry that operators can publish modules to and consume modules from that is freely available. Modules can also be versioned and detailed, making it very easy to use verified modules or pin version. And a developer or sysadmin or anyone actually looking to quickly provision infrastructure can reuse configuration modules by copying a few lines of code into a Terraform configuration file. And there's no need to rewrite the entire block of code. Modules allow for inputs and outputs as well that can be used by other resources and modules. We will go a bit more into that, a bit more in depth into that later in the demo. One second. There we go. Okay, that's right. Okay, sorry. Terraform consists of two parts. One is Terraform Core, the engine behind the Terraform workflow. Second is the Terraform provider. This is the extensible component responsible for communication with individual infrastructure providers. We'll come back to the Terraform provider in just a moment. So let's focus right now on the workflow. The Terraform workflow is consistent and repeatable. It's the same every time infrastructure is provisioned. And there are two primary steps to think about in this workflow: Terraform plan and Terraform apply. The first step, Terraform plan, inspects the Terraform configuration code as well as the current state of the environment being worked on, if the environment already exists and the state is already being tracked. It then creates a dependency graph to automatically decide resource deployment or modification sequence for resources that depend on one another. Like, for instance, a public IP is being provisioned to be assigned to a virtual machine. Terraform understands that the virtual machine needs to exist before the IP can be associated to it. Terraform plan also determines the resources, which resources can be created in parallel to optimize the duration of the provisioning step. The second step is Terraform apply. This step is the actual provisioning, and it executes the changes set forth with the Terraform plan command per the dependency graph and order of operations determined. These two steps are applied each time a Terraform run happens. So you've got one workflow, 2 steps, any infrastructure. And that's really powerful. Oh, there we go. Okay, so now let's cover Terraform provider model. Terraform providers are responsible for understanding API interactions for infrastructure as a service providers such as Azure to expose resources that can be easily consumed within a Terraform configuration. Terraform providers also include external platform as a service providers such as Heroku and software as a service providers such as GitHub. Providers are separate from the Terraform core engine to accommodate the rapid pace at which providers can be added. Additionally, new resources within existing providers can be created to extend existing providers as well. And so a few quick stats. There are over 70 providers that span infrastructure, 70 providers that span infrastructure, platform, and software as a service. And this number, it continues to grow fairly rapidly. We've also got contributions from over 1,000 community members. Within the providers, there are over 1,000 resources that span compute, networking, monitoring, etc. And these are added constantly as provider offerings grow. For those who have infrastructure in their own private data centers that are not a part of a mainstream provider, there's always the option of writing a custom provider to enable Terraform to provision and manage that infrastructure. Terraform providers use a CRUD API to communicate with resources. That's important to note. The extensible module, this extensible module means that over time, as new clouds and services emerge, new Terraform providers and resources would only need to be written for use in provisioning and managing those new services. So that's pretty awesome. The very foundation of Terraform is the open source project. So that's the primary foundation. It has been paramount in addressing the concern for individuals that need to create reusable configuration for infrastructure, that need to manage infrastructure in cloud at scale, and that need to use a consistent workflow over a diverse portfolio of infrastructure providers to safely and consistently provision infrastructure without the need to learn proprietary tooling for each provider. As Terraform adoption grows within a company, beyond a few users, because it usually starts out that way, 1 or 2 users, smaller use case. But once it grows, and as the organizational structure around that infrastructure management grows, there are oftentimes a set of requirements around collaboration and governance that become helpful to use with Terraform at scale in your organization. Additionally, there's also the element of support for daily and long-term success through enterprise levels of support. This includes both on-call support for daily issues, but also long-term architecture guidance and technical account management. This is what is offered as part of Terraform Enterprise. The focus of Terraform Enterprise Pro is collaboration, and Terraform Enterprise Premium is governance. As your team grows, you may find yourself needing the ability to restrict certain resources to certain groups. Maybe you need to ensure that the development environment for your application is only provisioned in the West US Azure region, where your developers are centrally located, but you need to ensure your production environment is located geographically closer to your primary audience in the South Central US Azure region. These types of policies these types of policy enforcement requirements are possible through use of a policy as code framework called Sentinel. Policy as code via Sentinel can offer more security in the form of theoretical guardrails that further protect your environment from misconfiguration or deployment issues. Okay, now we're going to get into the demo portion. Give me 1 second here to get this up. and running. Okay. Oops, okay, here we go. This is all live, And now it's proven. Here we go. So shortly you should see a console. There we go, looks like it's up. And this console is actually a repository, a demo repository that we built called Terraform Azure RM Demo. And it contains Terraform configuration files to apply to Terraform. And actually, I was going to do this a different way, but let's go over the files real quick while my account is cleaning itself up. Let's look at those real quick. And y'all should be seeing this here shortly. Okay, so I've got my Terraform Azure RM demo folder, which is my GitHub project for this demo. And so let's go over these files. And so this is a folder holding a few files. We need to pay attention to these .tf files here. The way that Terraform works is it loads all files within the directory specified that end with .tf or .tf.json. So Terraform can use either .tf or actually, I'm sorry. Terraform can use either HCL, which is HashiCorp configuration language, or JSON, and it's either one. It doesn't matter. HCL was created to strike a balance between human readable and editable, as well as being machine friendly. So whether you use .tf, .json, or .tf comes down to preference. They're completely interoperable. So in our case, the files that will be loaded by Terraform in my repository are here: bastion.tf, main.tf, outputs.tf, and variables.tf. So let's go through what each of these files is set up for in our Terraform configuration. We'll start with the variables.tf file. As you have guessed, I'm initializing and setting variables in this file. So you can see variable and then variable name and the default value. Some of these do not have a default value, and they're simply being initialized to be set up inside the other Terraform configuration to be overwritten. So that's really what this variables.tf file is doing. You can also set variables other places, but I've set them apart in their own variables.tf file just to keep things tidy. So let's take a look at the main.tf. Here immediately you'll see we're setting up our Azure RM Terraform provider. And so I've overridden these. I'm sorry, I'm using variables for these values here. And the reason I'm using variables is you would not want to hard code your subscription ID, client secret, tenant ID inside code. I'm instead using environment variables for these. So it's actually being pulled from my environment. So the main TF, it holds the primary configuration for our environment. In the provider, we have to configure it, obviously, and that's going to make all the API calls to Azure for us. And here we're setting up a resource group, an Azure resource group for all of those, the resources that we'll be provisioning. We're setting up a demo network with appropriate naming here, and you can see that we're also using interpolation. So you can see the dollar curly bracket. And we're reaching out, or we're pulling from Azure RM resource group default name. So what that also does, that actually pulls the name from this resource as it's built, as it's computed. What that also does is it helps build the dependency graph. So Terraform knows that this resource depends on this other resource being built and computed before it can fill in this value. Next, we're building a load balancer that we will be using in our demo. And you can see typical settings here, ports, the protocol, and something else to note. So we are using two types here. We're using resources and we're using modules. So a resource is actually built into the provider on Terraform. It's something that you can reference directly from the provider. A module, as we discussed a little bit earlier, is a pre-built bit of code, almost like a function or a method that I'm able to call. It's reusable code, so I don't have to put all of the code here. I only need to simply specify things that I need set per the module or that I need overwritten for my own requirements. And you can also notice as this right here, using the source Azure/load balancer/Azure RM would pull directly from Terraform's module registry, which is pretty awesome. But you can also set sources as local folders, local submodule folders, or as the remote GitHub repositories, and Terraform will pull down those modules directly from GitHub. So you can see here, oh yeah, I already mentioned this, we're building a load balancer. Now here we're building a compute group. So what we're building here is a virtual machine scale set within Azure. And that allows you to deploy a certain number of instances. In our case, we're deploying 3 Ubuntu servers. They've all got the same configuration and they're all going to be placed behind the same load balancer. And you can see that we have this command extension. This is basically saying, when you build these VMs, go ahead and run this command, which I'm just installing Nginx on these servers. And they'll be placed behind the load balancer here. Next, we're building a security rule to allow port 80 inbound. This is a web application, so we need to allow port 80 inbound to our network security group. And following that, we are allowing port 22 to our jump box, which we have not discussed yet. For those who don't know, a jump box, sometimes called a bastion server, is something that you place in your environment that allows connectivity into that environment for administration if you need it. Not everyone needs a jump box, but we're building a jump box for the purposes of this demo. And so that basically allows you to expose port 22 where you need it. We are doing asterisk for our source address prefix here, which you would probably want to lock that down much better. But for the purposes of this demo, we are allowing port 22 to this jump box. And so let's jump over to that actually. So we've got main.tf, we've got bastion.tf, and they're all loaded in order. So alphabetical order. Terraform will look at them in alphabetical order. But you can still require or use outputs from one .tf to another because it's all loaded. And here's the bastion.tf file where we're building that jump box. And you can see we're using resources here versus modules. We're building a public IP. Through the Azure RM provider, we are setting up a security group for this jump box that is separate from our network security group for the rest of the demo. We're setting up a security rule to allow SSH here as well, because this is a separate network security group, so we do need to add the rule here as well. And we're setting up our network interface for the jump box. And you can see that we are referencing other resources here. We're referencing the resource group name to set the resource group that it's going to be in. And this is all, again, it's building dependencies. You can also see that we're, for the public IP address that's going to be assigned to this interface, we are referencing the jump box public IP that we just created up here. And lastly here, we are building the actual virtual machine called JumpBox. And you'll see all of the normal things here. We've got the instance type that you need, the OS information, profile information, setting up a admin user, and a perfectly safe password. Please do not use password like this in production. This is for demo purposes only. And the last thing I want to show you here is this outputs.tf. So my demo, the demo that we've built, will actually output these bits of information. when running. So it'll actually output this to be used elsewhere. You can reference it as an output elsewhere, or if you just need an output to see these values. So I'm outputting the jump box public IP, its private IP, which we don't really need, and the load balancer public IP. And so let me see. I was trying to clean some stuff up here that was long running. Let me see if that's done real quick. And it is. Okay. So this is my Azure portal. Some of you may or may not be familiar with the Azure portal. And we won't go into that today, but I do recommend that you go get an account, check it out. There are a lot of services, a lot of things you can do in this portal. But I'm going to be using it here just to show you guys what it looks like when you're provisioning Terraform through your command line, what will happen in your portal. Let's go back over to the command line. So let me make sure I am in the right place, and I have the latest code from master, and I do. So as you'll see here, there are terraform.tfstate files. These are files that Terraform uses to track the state if you've already been building and using this Terraform configuration. And I have, but I've just wiped everything out. So I'm going to remove those files, make sure they're gone, and they are. There's also probably a Terraform folder here, yeah, and there is. And so that's a cache that's used by Terraform. So I'll just wipe all that out. That way we're just like we've just freshly cloned this repository so you can see what this looks like. And I hope everybody can see that. So I have, let me make sure. And I do. So this envvar.sh is basically, I won't show this on the webinar because it contains my secrets, it contains my tenant ID, my subscription ID, client IDs, also contains locations for the SSH keys I'm going to be using for this demo. And I want to mention, the entire demo is public on GitHub. We'll send that out later. But there is a very lengthy README that we've set up on that repository, so you can go back later and test this out for yourself in case I'm going a little too fast or what have you. So what I'm going to do is I'm going to source this file. And what that's doing is it's setting up my exports. It's setting up all of my environment variables that I've exported within that file. And that allows Terraform to pull those environment variables. Really quickly, Terraform can use environment variables for the interpolation as long as the environment variable starts with TF_VAR_, and then the variable name that you're going to be referencing. And so let's get back into the demo folder. Here we are. And we're going to Terraform init. So what Terraform init does is it goes through the Terraform configuration and it pulls any modules that are needed, any plugins that are needed based on what you've set in your configuration. And it also goes and pulls the source code for modules that you've mentioned inside of your Terraform configuration. So if you're, for example, we're reaching out to actually Nick Jackson's GitHub for some Terraform modules, it will go and pull those in. So now that I've done that, and my account, let's get back over here. My account is empty. If I look at my resources, all my resources, I have 0 resources. And my resource groups, I have a ZDEP Tau attest, a ZDEP Tau attest here. These are irrelevant because we're going to be using a completely different resource group, and you'll see that in just a moment. Before I deploy this too, I want to mention, I'm sorry I'm jumping all over here. The demo that we're deploying is a simple web application. It's going to have a Postgres database backend, and it's going to be a small demo app that will allow you to search through Ashley McNamara's Gophers. If you don't know who Ashley McNamara is or about her Gophers, please check her out. She is an awesome human, and she makes some awesome, awesome art. And so we're going to be demoing that a little bit here with an awesome demo that Nick has built for us. So that said, we've already initialized this Terraform working directory. It's already pulled in the modules, the plugins, the providers that are needed. So we're going to Terraform plan. So what Terraform plan is doing is it's looking at our Terraform configuration and it's building that dependency graph. It is saying what resources do I need to build, what order do I need to build them in based on dependencies from other resources or modules. You can see Terraform is going to be, and you can tell by the plus, it's going to be creating. It's going to be creating a network interface for the jump box, and here's all the information. You can see there are, you can see there are computed, I didn't mean to do that. You can see there are computed values. Go back up. Apologies. Totally live demo. All right. It's creating a network interface for the jump box. It's creating a network security group for the jump box. These are all the things that we just went over in the Terraform configuration. And Terraform is figuring out how to talk to Azure, get that done, and it's basically setting up the plan for what will actually happen. Now, it's not necessarily a requirement to run Terraform plan before you apply these changes, but it is always recommended to run Terraform plan and make sure you fully understand what resources are going to change. If something's going to be deleted or updated in place or created, you want to make sure you know what's going on. The good news about Terraform, and the reason Terraform is so awesome, is it's completely repeatable. So whatever you're doing is going to be repeatable and consistent. So if you test this in a development environment, which hopefully you will be doing before you push anything to production, you can rest assured that things will work as they have in development, as long as everything is the same. Of course, you still want to make sure you check out a Terraform plan when you're making changes. I can't reiterate that enough. So as you can see, all these things are being built. Create, create, create. I have no resources right now in my account, and so we're going to Terraform apply. So what Terraform apply does is it actually makes the changes, and you'll see it spits out this information again, so you can see what's going to be changed by this apply. You have to enter yes, Y-E-S, for this to work. So you see, here we go. We are kicking off. We are building resources in my account. And if we go back to, let's see here, if we go back to my portal, pretty soon, here we go. We'll see that it's building these resources. It's actually setting these up. And this will take a while to build. And so I think I will hand this over to Nick as it builds. And Nick, is there anything that you see that I might have forgotten in this project that we're working on together?
There's one major bit, Zach. How are we going to show these awesome Gopher images if we don't have a database?
Oh man, okay, yeah, I totally forgot that. So yeah, that's no good. Let me make sure.
Cool. It's cool.
Okay, and
cool.
I'm
just pulled your.
Yeah, I'm working from the latest information. Okay, yeah. So he's pulled my master branch here in my Azure RM demo. So yeah, Nick, if you want to take over and get that fixed, I apologize. I'm stuck here building these resources right now on my account.
It's fine. We can run through that, and hopefully it'll be finished by the time that's done. Right, bear with me. I'm just waiting for my screen to switch over, and then we'll take a look at this. So what we're going to do is we're going to sort of delve outside of the world of modules. So modules are an amazing sort of resource for creating sort of maintainable, manageable chunks. But sometimes things just don't fit into a module. So or sometimes you just want to do stuff outside of a module. So what I want to do is I want to just sort of show you some way of composing Terraform with resources. So bear with me 1 second.
And while Nick is checking that out, I'll show you guys really quickly the Terraform module registry. So registry.terraform.io is where you can go to see the public module registry, and you can see there are different providers available. You can click straight into Azure, and you can also click verified, which means that these are Azure verified modules. But you can see here we've got load balancer, network, compute group. You can deploy console, Nomad, Kubernetes, Vault, database, which I totally failed on.
I just totally trod on your shoes there, and I stole the screen away from me.
Thanks a lot, Nick. No, but, I can show this later. No worries, no worries.
Awesome. Sorry about that. All right. So let's take a look at this. So the first thing that you can see on the right-hand side is the main file that Zach was working on earlier, and that's composed of mainly of modules. So what we want to add is we want to add a database. So I'm going to add a Postgres server here, and I apologize for the noise on my keyboard. It's like the noisiest keyboard in the world, but it's literally the only one that I'm a little bit used to. So I'm just going to replace these placeholders I've got here with some names. So I'm just going to call my server Postgres server, and then what I'm going to do is I'm going to use some of the interpolation syntax, and I can pull in some of the variables such as the resource group name that we were using earlier, and we'll do the same thing with the location there. Now, with the resource group name, even though I've kind of got a variable for the resource group name, what I'm going to do is I'm going to use the reference. So if I use Azure RM resource group, which is the type, and then the name, so we call it default, and then I want to get the attribute, which is name from that resource group. Then what's going to happen when I run my Terraform apply is that I'm giving Terraform a hint that it knows now that it has to go ahead and create the Azure RM resource group before it can create my Postgres SQL Server. So I don't need to manually kind of tell it the order of any of the various different dependencies. When Terraform runs, it builds up a graph using these sort of links as a hint. So that just makes my life a little bit easier. All right, so what else do I need in here? So I'm going to create a database on my Postgres server, and it's imaginatively going to be called Gopher Search Production. I can set some various parameters such as the language and charset and stuff like that. And again, if you look at the resource group name, I'm using that interpolation. What I'm also doing is running Postgres server.test name. So again, I'm referencing a previous resource that I created so that Terraform knows that it has to create the server before it creates the database. Again, some extra stuff we need in here. So this is I think this is highlighting why modules are really good. If you do this a lot, you could build this up into your own module, but I need to create a firewall rule. And just like Zach was being super locked down with the SSH, I'm doing pretty much the same with my firewall rules for Postgres. This is not a great way to do this in production. You really should set your start and end IP addresses for your firewalls to the specific ranges that you're using. I'm just being a little bit lazy, and I apologize for that. But what we're going to do when we want to set a seed. We want to kind of load some of our seed data into this database. And what I can do is I can actually use this resource here called a null resource. And a null resource just allows me to set up a remote provisioner. So like a remote exec. And sometimes you can actually use these provisioners direct in your resources, but I just want to show you an additional way that you can do it. So with the triggers, what I'm doing is I'm saying if any of these values change, such as the firewall rule ID or the database ID or the sort of the jump box FQDN, what I want to be able to do is I want to rerun this null resource provider. And what I'm actually doing with a null resource provider is I'm running a remote exec script on our Bastion host, which is going to configure our database. So it's going to download the seed data from GitHub, and it's going to load that into Postgres. So you can do this a number of different ways. You can use a chef provisioner. You can use Ansible, however you want to do it. I'm just doing it the simplest way for me, which is just a simple bash script. But Terraform does support a whole range of provisioners. All right. So again, I just need to set up some stuff. So I want to set up the Azure RM. I want to get the public IP of the jump box, and I'm going to use the FQDN there. And the private key, I've got this stored in my environment variables, so I can just reference that from my environment variables. So private key is actually the private key data. It's not a reference to a file, but the kind of the contents of your private key. And I can save that. And my screen's a little bit too big, but just down the bottom. So I'm missing, there we go. Cool, so that's all saved. Now what I'm gonna do here is I'm gonna make a little change to the way that Zach has got the command extension set up, because he's just installing Nginx to sort of test this config and get it up and running. What I'm going to do is I'm going to change this about a little bit, and I'm going to run yet another script. So I have, using the VM extensions, I'm going to download this script from GitHub, which is an install script to install our application. And then I'm simply just going to run it, passing the references to our Postgres server and username and password. Nice and simple. And again, let's just I can run a quick plan on this so that I can check that everything's okay, so everything's fine. Let me just push this to GitHub, and then what I can do is I can quickly show you the Terraform Enterprise, which hit general availability today. And I can show you how that runs through there. So git add. So let me just push that. Oh, sorry. I might need to now we can push it to production. Cool. So that's gone there. So now, if I have a look at my Terraform Enterprise, we can see that plan is running in there, and this might be a little bit small for you to read there. Let me see if I can make this a bit bigger. But basically what's happening is I'm using Terraform Enterprise. So when I push my code to GitHub, it's picked up all of my changes, and it's telling me that I've got 4 resources to add, I've got 1 to change, and I've got 1 to destroy. So what I can do is I can just hit confirm and apply on that. And then what that's going to do is now it's going to run away and it's going to provision those resources in Azure for you. So this is pretty much the same way as what Zach was doing with the command line, but I'm just doing it with Terraform Enterprise. It gives us a little bit of workflow around the whole process. And it's a great way of sharing Terraform, the process of maintaining infrastructure with your team. So again, we've got some resources in there, and this is going to take a few minutes to create, because it's going to go away and create those SQL databases and stuff like that. So I'm not going to kind of dwell on that. You'll just have to trust me that it's all going to be great. And in fact, you can pull this config and you can test it for yourselves. But what I want to show you is a pretty cool feature of Terraform Enterprise, which is Sentinel and Sentinel configuration. So with Sentinel configuration, what I can actually do is I can create these things called policies. So what is a policy? So for example, here's an example Sentinel policy. So this is infrastructure as code. Terraform is infrastructure as code. Sentinel is policy as code. So what I'm saying with this policy here is I'm saying that, let's just read through it. So my main is my main rule. It's my entry point. It's kind of like my main function of an application. And I'm saying that all, which means that all instances, everything inside this block has to pass for the policy to pass. So I want to iterate over all of my Azure virtual machine resources in my Terraform plan, and I'm just assigning those variable instances. So it's very similar to how you'd write a for loop in a programming language, but it's designed to be a little bit more simpler, a little bit more human readable. And then I'm saying, again, I'm iterating over that instances collection, and I'm saying, of all of the instances, I want to check that the VM size is in allowed VMs. So if we look at the variable allowed VMs, I'm dictating that I can only create resources, which is standard DS1 V2 and standard A0. So this should work for my config. I'm going to try and save this and see if I can get it to work. So let's just say VM size. That'll do. And let me just change the level. So again, you've got 3 different enforcement levels. Soft mandatory means you can override it with admin privileges. Advisory, which means it'll only log the output. And then hard mandatory means the only way you can override a policy failure is to delete it. Okay, so that's saved. So again, if I go to here, you can see that's still running away there. But let's see if I can just queue my plan. So Terraform is telling me that I've already got something running and that I probably shouldn't run anything again, but I just want to show you Sentinel. So I'm gonna break the rules, and it's telling me that I can't. Okay, so we're gonna have to wait for this plan to finish before I can show you how Sentinel works in the execution. But I think you've kind of seen how you can write some Sentinel, and you can get a free trial of Terraform Enterprise. So go and try this, play around with it, and tell us what you think. But I think it's a pretty awesome way of working. And Zach, shall I throw things back over to you? Are you kind of is your stuff up and running, or do you want me to? I can kind of see stuff running here. Should we have a quick look at the demo of the application?
Yeah, go ahead and demo the application, being we're running short on time, and then we'll go from there back to the rest of the deck.
Cool. So this is what we've deployed. So we've deployed a very simple web application with a PostgreSQL backend, and it allows you to search in a very rudimentary form, I have to say. This is by no means Google search or Bing, but this is going to allow you to search for the amazing Gopher artwork that Ashley draws. So let's do a search for Microsoft. And we can see there we've got an amazing Microsoft Gopher. What about HashiCorp? HashiCorp. And again, we can see that there's some HashiCorp Gopher artwork. I'm just going to search for Gopher. There's got to be like a bunch of things which are Gopher. And again, we can see that there's a whole load of Gophers there. So all that's doing is it's just reading from a database that we've just deployed using the remote exec. It's deployed a simple Go application to our scale set using that simple bash script. And there we are. We've got our Terraform config. It's reproducible. We can rerun this anytime we want, manage our environment, and like do a million other things. Like the world is literally your oyster. It's down to your imagination how far you want to push this. And
okay.
Do you want me to run through the rest of the deck, Zach? Are you going to pick this up?
No, I'll pick that up if that's okay. And actually, I do want to try to show one more thing on the demo. I'm going to steal this from you now. Something that I'm going to talk about here in a second. Let me make sure this is working. It looks like maybe the screen share will not work. Here we go. All live, so bear with me. I want to make sure to show this if I can.
My provisioning's just finished as well, and it's worked, and I can't even prove that to you. You're gonna have to give me a minute. Like nobody will believe that a live demo will actually work, right?
No, never. Live demos do not work. Okay, let's see if I can make this live again. And we should be seeing my screen here shortly. And I apologize for the timing of this. Hopefully everyone can see that. So something I do want to touch on really quickly is the Azure Cloud Shell. It's this button at the top of my Azure portal. It'll throw you into a Cloud Shell. You can choose either a Bash shell or a PowerShell. But I want to show you that Terraform actually exists in the Azure Cloud Shell, which is really awesome. So you can see there is Terraform in my Cloud Shell. I didn't have to do anything. I didn't have to install it. What I did do was drop a very basic main.tf file that simply spits out a provider. And I just want to show that you can init here. You can plan here. It's not going to do anything. But I really just wanted to point out that Terraform now exists in the Azure Cloud Shell. You can go play with it. It's a great resource to get started with a low cost of entry. So Nick, if you're okay, I'm going to jump back to the slides if that's all right. Or yeah, either up to you.
No, you jump to the slides, and then we'll quickly just give me a minute at the end, and I can show this all working. Okay,
no problem. So we'll run through this quickly. So we've got some key milestones we wanted to show off from November to December this year. I just showed you Terraform in the Cloud Azure portal. Sorry, the Cloud Shell in the Azure portal. And the Cloud Shell comes with common Azure tooling installed, so you can work with your environment directly from your web browser inside the portal. So that's really, really awesome. I encourage everybody to go check that out. We've got 17 new modules in the Terraform registry. I was showing those a little bit earlier. I'm not sure if that got cut off, but you can go take this code, augment it, use it as it exists, and you can quickly build up infrastructure from these modules. So go check that out at the Terraform public registry, which is registry.terraform.io. We've got 9 new resources, such as, and these are new resources for the Azure RM provider, such as the ability to set a premium Redis firewall rule, virtual machine scale set, which is what we were building out in this demo through the compute group. Lots of good stuff here. We have lots and lots and lots of new resources in the Azure RM provider, and they're going to only continue to grow as we expand. We have provider updates in terms of 6 new data resources as well. And these are things such as the ability to access data about snapshots and subnets easily, to get information about permissions from Key Vault. Just a few examples of some of the new data sources that we currently have as of November, December timeframe. And over 52 bug fixes and improvements, which is super sweet. We are constantly, through collaboration and community, updating things. And so this is really, really awesome. Really, really awesome to see. And we are dedicated to getting this stuff solid and continuing to iterate on it.
Dude, I can't believe you left that image in there. That was like a mental placeholder to somebody to replace this image. That is so cool.
No, it's perfect. It's I mean, bugs are terrible. I don't think that was a terrible image, but yeah, it was decided to leave it. I apologize, Nick. And so, Nick, do you want to actually let's finish through the deck thing? We're out of time, and then we'll switch back over to you. So finally, go try all this stuff for yourself. It's awesome. If you don't already have an Azure account, we have free trials, a free trial that will give you up to $200 to use on any Azure product within 30 days. And you'll have access to some of the most popular products for free for 12 months, as well as I think there's more than 25 products that are always free. So I really encourage you to go give Azure a try. There is actually a typo on this slide I'm just seeing right now. Those resources listed, the first one should be aka.ms/tfhub, tfhub. So I apologize for that typo there. We also have Terraform, Azure documentation there that and you can also download Terraform open source from terraform.io. If you want to check out Terraform Enterprise, there's a free trial available. If you head over to hashicorp.com/product/Terraform, you can find more information there. And so, Nick, if you want to steal this back to show the final bit there, that was all I've got.
I certainly do.
I'm going to jump in really quick, Nick, while you're loading that, and just remind everyone, the resources that were just up on the screen are actually on your webinar console, up on the top right-hand corner. And down at the bottom of the console on the right-hand side is a quick survey that we're hoping you will fill out at the end of the webinar. Just giving us some feedback on what you thought about today's session and also what you would like to learn more about. So, Nick, I'll hand it back to you, and you can close it out when you're done. The questions that are coming in that we are not able to get to today, we will be sending out a compilation of all the questions and answers in the email that we send you within about 48 hours, which will also have a copy of the recording of this webinar. Nick, I'll hand it back to you.
Cool. So literally just to prove that I wasn't cheating, you can see that the apply there was queued 11 minutes ago, and it completed 6 minutes ago. We can see some of the output where I'm inserting the data into the database table, and it says that I've added 4 resources, and we've got some IP addresses there, and this is slightly different with the one I show you because it's running on a different server. So that worked, which was awesome. Now, what I want to show you is something that I deliberately got to fail. So you remember I put that Sentinel policy in there before, and I said that that I was only going to allow certain types of resources. Well, you can see that I've just pushed a change to GitHub, and what I did was I changed the VM size there. So I changed it to DS1 V3. And that wasn't in my allowed settings for my Sentinel policy. So when I've tried to run a plan, Sentinel has stopped me, and it said, the tolerances of your code that you're trying to pushing is not against your corporate policy. So it's failed, and It will allow me to go on because I've got administration privileges, but generally that's a sort of a category that's only available to administrators. If I was a normal user, I wouldn't have been able to override this policy. So again, like, go check out Terraform Enterprise, check out all of this stuff, have a play around with it, let us know what you think, hit Zach or I up. If we can help you, we'd love to do that. Some great stuff going on with Azure, great stuff going on with Microsoft and Terraform. We're all super excited, and like, I hope you are as well. That's pretty much everything.
Thanks so much, you guys. It's such a great presentation. Thanks so much, you guys.
So that was it. I just wanted to close it. We will follow up with the queue, all the questions that are coming in. We apologize that we ran a little bit long here. And thank you all for joining us for this webinar today. We really appreciate it.
Thanks very much. Have a great day, everyone.